What I want to encourage everyone to do is to open up your favorite projects on GitHub or wherever they're at and get pull requests and issues ready, because I'll be discussing common performance oversights in popular libraries and possibly in your own code. So if you find something that's useful, tweet it. There's hashtag Perf Forward. And at the end of the talk, I'd like to see like a list of hands of how many, or show of hands to see how many issues have been reported or pull requests have been started. So cool. All right, a little bit about me. I'm co-maintainer of JSPerf.com. How many people have used JSPerf.com? Awesome, cool. Wow. I'm also the lead dev on Lodash. So Lodash is an underscore alternative. How many people have heard of the Lodash? Awesome, sweet. And then Benchmark.js. And Benchmark.js is what powers JSPerf. And it also allows you to do things on Node, Ringo, Rhino, all the browsers. And then I'm also a Perf PM at Microsoft. So I help make Chakra, the JavaScript engine, faster. Woo. All right, I'm back, kind of. Cool. And by looking at patterns, popular patterns on the web, and helping relay them to the C++ Java engine devs. And I am a JavaScript fanboy. So before I begin and talk about the specific performance tweaks, there's a couple of themes that I'll be trying to reiterate throughout the talk. And that's optimize for the common case, optimize for the common case. Whenever you're implementing a API design or using a library, if you are a library author, think about the most common case for that API to be used and optimize for it. Everything else is secondary at that point. A lot of mistakes I've seen when devs are doing APIs is they're putting things in their code that slow things down for no reason, or for this edge case, this scenario. Next is using natives wisely. Last year I gave a talk at JSConf called The Hidden Cost of Natives. And that was looking at the performance of native methods like array for each, filter, map, and then comparing them to alternatives written with for loops. Also things like bind as well. And then avoid abstraction. One of the easiest ways to gain performance in a JavaScript library or a JavaScript project is to just peel back a layer of abstraction. Reduce those function calls. You don't have to go crazy. You don't have to compile all the things like method compilation. But just pulling back a layer of abstraction can help you with your perf. And then to balance the pros and the cons. Everything I'm talking about here is just advice. If you're not seeing a performance issue, then you certainly don't have to refactor your code and run out and do it. I work with a lot of like low-level library functions where they have to be fast because you don't know what's going to be built on top of it. It's the baseline for a lot of projects. And so keep that in mind when I show, like, I'll show one way to implement something, and then I'll show another way to implement it that gets a little bit deeper. And then, you know, code kind of increases and complexity increases. So you just have to judge for yourself. Like, do I want to pre-compile all things, or do I just want to maybe just remove one layer of abstraction? So, cool. Now that that's out of the way. All right, so I also hope to blow some minds, and I just love this GIF, so there's that. Let's just absorb this for a second. How awesome. It repeats forever, too. I love it. OK. OK, so the first technique is to hoist out .call and .apply from your iteration functions. And then I put a little key down here at the bottom that shows the libraries that this applies to. So if you use any of these libraries, this technique applies to that, and you can create a patch for it or an issue for that library. So that's Backbone, Dojo, Ember, jQuery, Prime, which is MooTools 2. And then underscore. And I'm sure there's more. Every library has some kind of iteration utility. Every library has some kind of event loop or event emitter. And this technique can be applied to those. So the general gist is we've all seen code like this, while loop, callback.call. And what it's doing is it's doing the .call for the this arg, your this context. But if you don't pass a this context, it's still, or this arg, it's still doing a .call. And that is slower than just a straight function call. So one way to do it, like we all know that when you have loops, you move the hard work out of the loop. And in this case, you can move that .call out of the loop by doing something like this. So this create callback allows you to evaluate and do the binding inside this function here, and then in your main loop, you've just got a straight function call. And so that increases your iteration performance and your event emitter performance. And the inside of that function there that I've highlighted looks like this. Oop. Aha, there it is, like this. If you don't pass a this arg, it just returns the callback. And if you do, it wraps the function and does the .call. Now, this makes your common case very, very fast. And I'll show you, I'll step back. This is, I applied this optimization to Backbone, which already has a very fast event system. Like, they go out of their way to really fine-tune it. And you're still able to get performance gains in various browsers because of this. And I'll step back or forward. There's trade-offs for this. This makes your common case very fast. This makes your case where you pass a this arg very slow because it is having to do a function wrapper. So there's variations you can do on this. What you can do is you can check to see if there is a this, I'll show you here. If there is a this binding, and then in your loop, do a conditional share, like a ternary operator there that says, hey, if there's a binding, do the call. If not, or do the function call with .call. If not, then do .call. And that will give you a little bit better performance and not as big of a perf penalty. So it's just up to you to weigh the pros and cons of your approach. One of the good things about using create callback is that with this approach, you could then add extra functionality without having to modify this function. You could just modify create callback. So I did this with Lodash. For our map function, usually there's a function called pluck, which would then you give it a collection or an array of objects, let's say, and you want to get the name property value off of all the objects. There's a function called pluck, which would do that. Well, instead, you could have map, which we all know what array map is. You could have map that accepts a string for callback. And it would pass here, and it would automatically create the callback that does the object property retrieval for you. And it's at 0 perf cost. So you're able to extend your existing iteration function without any extra perf cost, and it's optimized for the common case. So you get win, 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 win out of that. All right, before I get into the next one, I also want to touch on event systems like jQuery. So if we looked back at this chart here, you saw that, so this is higher is better, so the longer the bar, the better. Backbone Alt is my implementation. You'll see, like jQuery's version here, their event system is considerably slower. But they're doing a lot more. They've got a more robust event system. It's for handling elements. It's not just generic objects. And with this technique, you can improve jQuery's event iteration by like 18%, which, considering how much other stuff they have around, just removing that .call and .apply is a pretty easy tweak. So if anyone digs jQuery and wants to optimize that, this would help their event system. This would help their .each. So, cool. All right. I really like this technique. And so you'll see a lot of this stuff is I've taken out of Lodash because I'm not just like coming up with ideas for optimizations. I use these in my own projects, and I've tested them, I've refined them to try to gain performance and to offset the cost of like bug fixes or compliance. All right, so avoiding binding. How many people know that you can coerce a function to a string and access its function source? OK, cool. You may also know that it's non-standard technically, but it's like a de facto standard, like everyone kind of does it. So I found a way to avoid the this binding if you can detect that the function isn't using the this keyword. And so check this out. yeah. So it's so, by the way, this is going to be in Lodash as well, so expect it. For those that are like, wow, that's not standard, I'm kind of scared of it, in another slide I show you how to do a feature detection for it, so you can get this benefit if it exists, and you can drop it if it doesn't. But the gist is, and this is me showing like a generic event system that you could patch, so you could do this with jQuery's event system, for example, or Backbone's event system. And usually when you're registering an event listener, you might pass in some metadata. So like right now, I'm passing in like the function and its context. But what I'm doing is I'm testing to see if the function is using this reference. And if it's not, then I'm not going to do a binding to it. And so that will speed up the iteration there, because it's not just doing this implicit this binding if you're not using this. And this also allows you to say to your devs that if they do care about performance, that you can actually enforce a different coding pattern for them and say, all right, well then just do var that equals this, which is gross. Some people hate it, but if you need it, your system will now allow for it and actually have optimizations for it kind of backed into it. So that's this technique. I'm using function.prototype.toString because this avoids issues if the function has a custom toString. So like I've seen charting libraries do that to their instances and objects and functions. And so this way, that even avoids that gotcha there. What this will do is this may have false positives if you have a comment that has .this. But in that case, the worst case scenario is that it's treated like every other function and wrapped or bound. So just if you know that this could be a pattern for you to increase performance. So what I'm doing is I'm adding this to my iteration sugar in Lodash. So if you pass it this binding, but your callback isn't using it, it's not going to actually do the bind, so it's going to hit the fast path. Because I showed you that that slow path is considerably slower for me, because I do the create callback technique. All right, so here's the feature test. For example, that one up there. So I do an assignment. I test to see if I can find this value. If I can, then I return the value. Else it'll be false. Then you could do something similar. This was just a cheap way to do this. What I've done in Lodash is to use the running context method, because it's the method that wraps everything. So it's a very big function body. And this allows me to detect issues with mobile browsers that may truncate function body strings. And so I reference this like way down there in the bottom. So if they can catch it, then I know it's probably safe to use. All right. Let's see. This is me actually showing the inside of the listener. So before I showed how to register it, and this is an implementation of it using that information now. Now that I know that I can conditionally, if there is a context, call it. If not, do a straight function call. And that is how you get your performance. Now, this is kind of like the Backbone's implementation, where they do a switch statement on number of arguments. I just did up to 1, but they do it like up to 3. You may do 4. It minifies to almost nothing. So if you're totally grossed out about that, just say it's for perf, and move on. Yeah, okay. All right, so the next technique I have is reduce your searches. So a lot of people, when they have a large array or a group of arrays, they want to do operations like without or union or unique on their arrays. But that's doing a lot of linear searches, index of values going through the collection every time. And that's very, very slow. And to fix that, you may think, well, I'll just use an object cache. So if the value in this case turns the value into a property name, and they set its result to true. So then if it does exist as a property, then they know it's there, and they can continue on their way. They've found the property, or the value. But there's a couple of problems with that. It conflates things that look like identical as strings. So like the number string, or the number 2 and the string 2 look the same. And so if you're doing something that is like a unique operation, it's going to treat them as equal when they are not. Or even a function that coerced to, for some reason, coerced to a number. it would, with toString, would do it. So that approach doesn't work well for generic use. Now, if that is your only use case, then maybe you could do it. But this is how you could tweak that. So here's the first one where it's index of. And you'll also see that I've got a little bit of something up here. But I'll talk about that later. And then the tweak is what I've done is I've, in this example, created a cache of that value. And then I just look to see if it's contained in that cache. Or if it's not contained in this case. And now I'm going to go into actually showing you how I create the object cache for that. So this is what the idea is instead of doing a long linear search, you're breaking that massive array into smaller buckets. So you're taking all of in my previous example of 2 like values, so all of your number 2s and string 2s, and sticking them into a smaller array. So you have less of an array to search. So that should be faster, and it is. It's considerably faster. And so now here's just the small code that shows you an implementation of this. What I do is I detect if the array is large. And what is large? It's an arbitrary number that I've created based on research. So in my case, my implementation, the large array size was at one time 200. So anything over 200 got this optimization. Now it's reduced to 75. So now any array over 75 gets this optimization. But what it is it's the point at which your cost for doing this actually gives you a perf win, because you're having to sit there and create an object and populate it with properties. And if your array is 4 items long, then it's not going to be not going to be a win. So what this is doing is I'm doing a prefix here for the value to avoid issues with object properties on objects prototypes. So toString has own property. It also avoids issues with the magic proto property, double underscore, proto, double underscore. And that is the implementation there. I basically push the values into their smaller buckets in this cache. And then in this function here, I check to see if it is in that smaller array. So instead of doing, let's say, 200, a search over 200 items, it's doing a search over 4. So it makes it faster. Now, this is me zooming into that chunk right there. That is what's actually creating the cache. But it was pretty clear before. So there's an alternative technique that you can do that takes it another step further. And this is what I'm doing in the next version of Lodash. And what this is instead of creating a bunch of smaller arrays, what it's doing a hybrid approach of the first naive approach, which was to do object properties, and it's also doing arrays. So object properties for things like Boolean values, false and true, null, undefined. And I only do those lookups if I'm looking for a value that is one of those. So it's not going to get a false positive like with the number 2 and the string 2. And then I have an object cache for anything else that's an object, so then they'll get their own arrays there. And this is just me creating that cache again. Still, if it's an object, it's getting pushed into the smaller array. If it's one of the other primitive values, it's being set to true. So that's the hybrid of the naive approach and the smaller bucket approach. And this gets considerable wins. This allowed me to reduce the size of my large array limit from 200 down to 75. So that means more arrays are impacted and more you get better performance out of it because your optimization kicks in earlier. Cool. All right. Another technique is, oh, by the way, that optimization can be used in underscore and possibly jQuery. Another thing you could do here is coerce values with care. A lot of times, devs will get in the habit of doing slice.call arguments all the time. Just whether they need to or not, they're slice.calling arguments. And in many cases, you don't have to. Arguments are an array-like object. If you're about to iterate over arguments, you don't have to convert them to an array. You can just iterate over them straight up. And many times, you can avoid slicing them if you are going to iterate over them. Just set your I index or your index value to 1 or something, so you don't have to slice them. There's an example here where I've done that, where instead of slicing your arguments and doing an index search, actually I missed a value there, but use your imagination, there's a value there. Argument. Instead of that, I'm leveraging the from index of index of. So index of, an array index of, in this case the library index of, allows you to set a from index where you start your linear search from. So it doesn't always have to start from 0. It can start forward. So you don't have to slice things there. You can also avoid things like concat. So let's see. Dun, 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 dun. I have a typo, which is lame, but I'll jump down to this example over here. Instead of flattening, a lot of times devs will include a lib to flatten arrays, and you don't have to. You can use native concat. Concat flattens arrays. So in this case, I have a variable reference to concat. I also have a variable reference to slice. So if you see slice up there without anything, that's me storing var slice equals array.prototype.slice. And instead, you can use concat to flatten your arrays. And you don't have to pass it an array as it's this arg. So I've seen many libs do this, where they're just creating garbage, like extra unneeded arrays there. And you can tidy that up. The array.prototype itself is an array, so you can use that as the this value there, which is what I do in Lodash 2. And I believe it's been added to underscore. But that pattern there is from jQuery. So if you're jQuery fans, you can go and patch that up. And I'm sure you could find it in all the other libs too. They all kind of do similar things there, and you can tighten up their dead object creation. And then the bottom one is avoiding concat when it's not needed. So in this case, they were doing foo.concat slice arrays, slice arguments, and you can avoid that and do like push dot apply and push, because push accepts more than just one argument to push. I don't know if how many people knew that you could push more than one argument? Okay, cool. Well, you can, and so you can leverage .apply there and push all of your arguments onto the array without having to do concat and creating all these intermediate arrays. So try that instead, and that's me again having a reference to array.prototype.push assigned to a variable push. Okay, sugar in moderation. How many people use jQuery's chaining syntax? Not jQuery's, underscore's chaining syntax. Okay, a few. If you're using a lib that's optimized for the generic use, you need to be aware that the chaining syntax, the non-common syntax, has a performance penalty. So if you have an animation framework or a tight loop, try pulling it back to the API that is optimized for that library before you even have to roll it back to like for loops or go crazy other optimizations. And in this case, I've shown the difference between the two there. You've got the chain version versus the generic version. And there's a trade-off there. One is pretty, and the chaining API is very pretty. But the other one is actually how it was designed to be used from its core, so it's faster this way. Keep in mind the differences. Underscore and Lodash are optimized for their generic use, but mood tools and anything that operates on a prototype, so that even means jQuery, are optimized for the chaining syntax. So be aware of the libs you're using. Be aware of that in your own code too. Like if you're doing something that's moderately performance intensive or could be, make sure you're using the API that's appropriate for your use. All right. Next I wanted to say is, with the chaining syntax, if you do have a chaining syntax, there's an optimization opportunity there. And that is deferred evaluation. So just a week or two ago, I saw a library come out that was called Lazy.js, which was boasting better performance than Lodash. Haha, it caught my attention. Because yeah, I'm pretty competitive in that space. And now normal usage, you could see I beat them. I beat underscore 2. Underscore is the little blue. I'm the big blue. But as the complexity of the chained functions increases, this one starts to win and win by a considerable amount. And that's because what they're doing is instead of doing 200 iterations for map and then doing 200 iterations for filter and then doing some other things in their collection, so iteration, 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 and then at the end only getting the last 5 values. Lazy evaluation at that time doesn't execute that at all. It adds it to a queue. And then whenever you call toArray, or in this case, like if you're familiar with the underscore lodash chaining syntax, the value command, or the value method, that's when it flattens that down. And instead of it being 200 or 400 or 600 iterations, since you're only needing 5 values at the end, because you're saying like take the last 5 values, it only does 5 iterations. And so that gives you, massive performance wins. So as your chaining gets longer, you get better wins. Now, I'm experimenting with adding support for this because I liked it so much and I like the performance opportunity. My chaining syntax is usually a perf hit because it's, like I said, lodash and underscore are optimized for the generic use. But I can back this in. Whoops. Hey, Matt. No, it's cool. Let's see. Boop. Someone's birthday. All right. Yeah. All right. And that's it. Questions?
John.
Yeah.
Hey, when you're writing the tests to sort of determine how well your library or other libraries perform, isn't the concept of general use case kind of subjective? Like, how do you write tests that you feel are fair?
So general use case is the use case I've seen promoted throughout like documentation or through tutorials. So in my case, I know that most devs aren't passing this value there. So I know that the common case is not to do that. It's being familiar with your own lib, being familiar, especially if you're the lib author, being familiar with how you want your devs to use that API and how you're promoting it through your evangelism. And then you know what the common case would be, so you can optimize for it. Going back to the themes again, where I said optimize for the common case, jQuery has an implicit this binding in its event system. Because if you're doing .each or whatever, you'll see this equals is the element that's currently being iterated over or something. And that was baked in from the beginning. So it's hard to kind of back in perf there because they're always doing .call or .apply. But if you want that 18% boost, what you can do is do that function sniff inference where you can detect if this binding is there and toggle it. But you wouldn't have to go to that length if at the beginning you said, oh, OK, maybe not all are going to use this, or maybe this will become an anti-pattern or whatever. And they could instead have put that property on the event object that they're already passing down. And so that would have avoided a .call to begin with. So when you're doing like your event system, you could think, oh, maybe I don't need an implicit this. I could just add a property to the event object that I'm passing to every callback anyways. And so just kind of keep these things in your head as you're developing your libraries or your own code bases. So yeah, cool. Yeah. So the question was, have you looked at any of these anti-patterns in CoffeeScript? I don't use CoffeeScript, so no, I haven't. What's nice about CoffeeScript is it just boils down to basic JavaScript. And in many cases, its sugar boils down to for loops. So that's right up my alley. Like, it doesn't defer to native methods. It turns it into for loops. And it has small utility functions, which are very nice. Also, I'll be positive about CoffeeScript and say I like its class abstraction. But yeah, yes.
So with the regex sniff for disk,
Uh-huh.
have you seen that like perf hits from the actual regex taking a while, like function? Is that a concern?
I need to do more research there, but I do have the big function on mine. I only do it once, though, for the feature detect. But so far, it's given perf gains in the tests that I've done. You could always do more research, dig into it. I'm going to try it. I'm going to give it a shot because I think it's relatively safe, and stable, especially for modern builds. So what I'm doing is I'm opting that into just modern builds. So just IE 9 up and modern browsers will do this, not old browsers, because that just means bugs just, yeah, and bugs get big. Well, the idea is that I'm doing that work outside the loop. So it's done once outside the loop instead of like every time inside the loop. So it's, again, hoisting things out of your loop. So cool. Yes? Yeah, good question. So the question was in create callback, which was the code I have up here. And I'm going to get to it. I can't speak and move at the same time. Okay. The question was, in create callback, why not use function.prototype.bind instead of wrapping? And that's because many times in most browser implementations, function.prototype.bind is actually slower. Especially like in V8, it's considerably slower. And Lodash actually is aware of this and will not use native bind in V8. I do an inference for its engine, which is really cool because I can detect the JS engine through a little inference. But even in browsers where it's relatively fast, or faster than a fully spec compliant bind alternative, bind is still slower than just wrapping it. So I thought I was going to get a perf boost there too, and I was really surprised that it didn't do it, or else I would have, yeah, done that. What's up? Yes? For the purpose of this demonstration, I kind of wanted it really simple to just do word boundary this, word boundary. You can experiment with other variations of it if you see that as a problem. I don't know if I'm going to see a lot of people having that issue. But if it is and if it's a concern, I still kept it simple. That way it's just a quick regex that just finds it or fails fast. But yeah, you could modify the regex to detect comments. I don't know if I repeated the question, but it was, could you modify the this regex to look for comments instead? Any other questions? Yes?
I'm just kind of like a little bit if the title was not doing some of this stuff. I was curious, ask you like a philosophical question.
Yeah.
Where are you drawing the line between your code running faster than your code running assumptions?
Mm-hmm. Yeah, so I had a slide here that I removed, which was how to better, to have create call be better detected for inlining, because some engines have an issue with that function call out there. And so what you would do is do a check for if this is undefined, don't do the function call at all, and just have it be the callback, so a ternary operation of that. Engines are tricky. Engines under the hood they're doing all kinds of crazy stuff to just get the result and get it fast in JIT and what gets optimized and what doesn't. This is why I said it's a balance of how deep you want to go into it. And I think this is a decent trade-off because it's not just, it's giving me win on top of win here because it's optimizing for the common case and allowing me to extend functionality for each and other iteration methods to have like the callback shorthand sugar of the property access or partial object filtering. So that's what I dig. A side note is, since we're talking about engines, is that I've noticed that minified code will have different performance profiles than your non-minified code, potentially, in different engines. So if you're developing a project and you have a performance critical thing like an animation lib or something, you want to test your minified code in your benchmarks as well as your non-minified. I found issues with Uglify.js and Clojure compiler where they, because of their patterns they're using when they minify, de-optimize like Safari and mobile Safari. So again, really, really good to test that. What I've done is in Lodash, I have a minification system where I run all these minifiers and then get the smallest build. But then I also go back and I fix the the patterns that the minifiers are doing that slow down the engine. So I avoid the deops. But it's something to do. Like if you don't have a perf suite for your library, you should create one. And if you have a favorite library and they don't have a perf suite, you should add one. And a perfect lib to do that is benchmark.js. And you can look at Lodash's implementation for example of a perf lib. Any other questions? Yes? No. Without you just each engine is different. Each engine has its own rules. With that minification issue, what was happening was I believe what was happening was that the minified code was not getting inline for some reason. It was passing some threshold of bytecode or whatever, and it was missing the inlining opportunity there. And so it was reducing its performance by 30%. So it was pretty glaring. But as to what gets inlined and what doesn't, the general rule is to keep your functions small, and then they have a better chance of being inlined. And that kind of goes at odds with my other point, which is reduce abstraction, because you're going to have all these function calls. So I would say profile and then make your decision. Don't just take my word for it. That's why I also didn't include a lot of performance charts, because all you'd see is these bars with them being really big over here and really small over there. And I want you to not take my word for it and to actually go out and use JSPerf and other benchmarks and verify that you get these wins. If you do a pull request, back it up with a performance benchmark. So you can say, hey, this actually does this. And if it doesn't, then it's still good. You've learned something, and you know not to do it in that certain situation. So, yeah.